go from there to talk about the race for a vaccine. What's sort of the reality of looking for a vaccine? I know we have to make a new flu vaccine every year. Are we like, will the coronavirus vaccine have to change? Sort of, what's the rundown on the vaccine situation?
Yeah, vaccine, yes, right now there is hundreds of candidates. I think last time I heard there was like 200 something. So there's a lot of vaccines in development, which is great. There's 3 types of vaccines, I think, that are in stage 3 already, trials. The one that's the most advanced right now is the Moderna vaccine that is being tested all over the world, mostly in US. And that is sort of stage 3, which means that there is like, I think, 30,000 people or so being enrolled in that trial.
Oh, wow. That seems like higher than I had in my brain. So 30,000 people in the world are who haven't had COVID, who we think haven't had COVID, are being vaccinated with this trial vaccine?
Yeah, so basically in these trials, the stage 3 tests whether vaccines are effective. And that involves half the people get the vaccine and half the people get the placebo. So they don't get the vaccine.
Mm-hmm.
And then based on how many people who got the vaccine get sick versus how many people get the placebo get sick. So sadly, this trial actually is based on the fact that people who are in the trial will actually get sick. So they're actually looking for infections and trying to see infections in the control group and no infections in the vaccinated group. And those people obviously don't know what they got. And that's the whole idea that the effectiveness, efficacy of the vaccine. So there's been several of those, and one of them has been stopped because of one severe reaction, and we still don't know whether it was a random rare event or it's something about the vaccine that caused it. And that was the Oxford vaccine.
So by rare reaction, someone in one of the trials got like really bad coronavirus disease?
No. They got reaction to the actual vaccine, basically had a severe reaction, and there is investigation right now. And because anyone can have some kind of a bad health problem, maybe directly related to the vaccine, or maybe it's just a random event, because as I said, there's thousands of people being vaccinated, so it's kind of under investigation. So one vaccine was stopped, and depending on whether that was a random event, a rare event, or it's something that vaccine could have caused, then they will either continue after they investigate it, or that vaccine will not be good.
Right. Okay.
There are others, and that's a good thing. There's a lot of different formulation, and hopefully some of them will be at least partially effective, because to make a difference, vaccine doesn't have to be 100% effective.
Right.
Even 50% effective vaccine would be great. But anything below that, that's not good.
Right, because then you're getting... Yeah, so the 50% effective is like the threshold, but once it crosses that, like, we'll take it kind of thing?
Well, the thing is that depending on how it goes with these trials, they could terminate them early for various reasons. And one reason could be if they get enough evidence that the vaccine is effective, they will implement it, and they will inform, so they will unblind it, and they will inform everyone who received the placebo received a placebo and now they can have the vaccine, because if vaccine is proven effective, it's sort of unethical to keep people who got the placebo still as guinea pigs.
Right.
So that's why most of these trials, they are projected to go for years. But like the Moderna one, I think is like till 2022 that the trial is going. But anticipation is that the results will be available, like the first indication of whether it works will be available way earlier than that, and they will essentially terminate it and unblind it and do the next phase. So it doesn't have to go to 2022. Well, I hope it doesn't go to 2022 because we need vaccine now, right?
Yeah. So what would the next phase look like then? What you described, like unblinding it and saying, hey, this is, at least 51% likely to work. Come on in and get your vaccine.
Yeah, pretty much. So they will probably expedite it and accept it under emergency. Well, in US for sure. In Canada, I don't think we are part of this Moderna development. I think Canada have participated in 3 different other candidates, but I don't know exactly, to be honest, which one of them is the one that the Canadian government secured the provisions for to manufacture and distribute in Canada. So we'll have to wait for those. But the Moderna is just the one that's just furthest along right now.
Right.
And that one, everyone is expecting, because there are many ways to make a vaccine, and there are many formulations and many platforms and types of vaccines. And it doesn't really matter which one works, and maybe many of them work, which would be awesome, because then more people can get them faster. The anticipation is that some of them will work, at least to some acceptable level.
So can you explain that to us? So if there's 10 people or 10 vaccines in the works right now across the globe, and we've got the Moderna one that we're pretty sure is going to work, and Canada's like working with its own. How is it possible that more than one can work? Like what's happening then in the vaccine in relation with the virus that there can be more than one that ends up working at least more than 50% of the time?
Well, because so there could be potentially a situation where there's many different vaccines that all work, and it's not something uncommon. For example, in flu vaccines, we have different kinds of vaccines that are manufactured by different manufacturers, and they have slightly different properties. We have quadrivalent, we have trivalent, we have live, we have killed, we have adjuvanted, not adjuvanted. So they all work, and they're all different, and depending on which ones are recommended and which ones are physically produced in enough quantities to vaccinate here in Canada, then those are the ones that are deployed in Canada, but they're not necessarily identical to the ones that are, say, in US or Europe or China or elsewhere. They're similar, but they're made by different companies, and they might have this slightly different composition, as long as they all work. So the same could happen with COVID. So Moderna, if it ends up being good, it doesn't mean that everyone is just going to get Moderna. There are hundreds of vaccines in development, so some could later be realized that they're actually better, and some will be worse. And it's like in any free market, whoever gets the best product, that wins, but doesn't necessarily that this will be the only product that will be be a choice. And chances are there could be different vaccines for different age groups. Some vaccines could be more effective against seniors. Some will be more effective in younger people. It's possible.
Is that hypothesis around because the disease presents itself so differently in different ages, or like?
No, I think it's just because in older people the immune responses are weaker, so you might need vaccines that have stronger adjuvants or higher dose, or there's always a balance, right? Because you don't want too much of the immune response because it would be harmful, and you don't want too little immune response because it won't protect. So there is a balance there. So that's what the trick with all the vaccines, right?
Right. Okay. And then why can't, like, say Moderna works and it gets the green light, why can't you and your lab just go start making the Moderna, like doing exactly what they did?
Well, first of all, because of copyright, just cannot infringe on that copyright. They would certainly be happy to sell to everyone their vaccine. But there is, of course, the priority and the capacity to be considered. So that's why so many countries are developing these vaccines. Because even if, say, China, for the sake of argument, or India would get the best vaccine. Well, there's 1 billion people in India, more than that, and they all need the vaccine. So it will be a long wait before they vaccinate everyone there and make enough vaccine to spare for Canada and US and Europe and everyone else. So that's why many countries are racing to develop vaccine, because then they would have an easier time getting enough of it soon enough to vaccinate their own people.
Right.
Because it's not trivial, right? It's millions and millions of doses, and they all have to be produced to the highest possible standards. God forbid something is bad quality, and we already have so many vaccine denials and vaccine hesitancy and all that kind of stuff. Vaccines don't need any more bad rap, so they have to be made to a higher standard, and in millions of doses it's not easy to do, so it's a long process.
Okay. How long? I have like 4 questions based off that. My first one is, have vaccines always been under copyright law? Like, how long has that been the case?
Well, it depends, right? It depends how they're developed. Sometimes governments have a stake in development, and that gives them some control over. I know Canada is participating in development of some of the vaccine candidates, and in return, those companies that develop those vaccines promise to give Canada priority access and set up manufacturing and that many doses in that many months and things like that. But this is all hypothetical. It's kind of like futures trading on the stock exchange, right? You kind of stack your bets against certain things, and then you hope for the best. But in most cases, it's the companies that develop those vaccines, because in many cases, that's how all essentially drugs and treatments are being developed. Sadly, the governments don't really have their own treatment development facilities. They're usually in private hands, so that's unfortunately how it works. And sometimes it's bad, sometimes it's good because it's faster and more efficient. And unfortunately, I don't know of any examples where a vaccine would be developed entirely in the public domain.
Right.
There's usually someone holds a copyright. And even with, say, flu vaccine, for example, I believe it's GSK or Sanofi or some big company that provides the vaccine for flu vaccine for the entire vaccination campaign in Canada every single year. And of course, there's cost benefit because Canada buys in bulk, so we get a discount, right?
Right.
So vaccine is free for every Canadian, and Canada doesn't pay as much as some other country who doesn't buy in bulk, or if you were as an individual to go to the pharmacy and somewhere and try to get your own vaccine.
Right.
But it's all a competition between different manufacturers and see which one works best.
Crazy. And then with that, so you were talking, there's possibly different vaccines, and they've all got sort of like different tweaked chemical or molecular makeup to fight the virus. Is that in any way similar to, or like setting us up in any similar way for sort of the super bug as a result of antibiotics that we're seeing, or is that separate?
No, I don't think it works the same. So the viruses, they change all the time. So we make a vaccine against one virus and then it evolves and escapes and we need a new vaccine. That's what happens with flu. And it's not anyone's fault or a bad strategy. It's just that the viruses are really, really good at changing. And now we already see that the COVID virus, the SARS-CoV-2, is changing already as well. And so far, there's no indication that there's any variants that would escape vaccine protection. But with time, it's totally possible. And vaccines would have to be reformulated, just like flu vaccine.
Right. Okay. And then how long does it take to make a vaccine? Like say, and I know you said it all depends on like scale and how big the facility is or whatever, but like, what are you actually doing when you're making a vaccine? What's happening? And what's sort of that process from day one?
Well, it depends on what the vaccine is made in. So what kind of vaccine it is. So there are vaccines that use killed virus. There are vaccines that use different virus that has parts of the COVID virus in it. There's mRNA vaccine, which is essentially a chemically produced piece of nucleic acid, and that's the Moderna approach. They just have the RNA vaccine. So there's all kinds of vaccines. So depending on that, the actual manufacturing process is different. Flu vaccine is made in eggs, so you need a lot of eggs.
Like chicken eggs, the flu vaccine's made in?
Flu vaccine is made in eggs and chicken eggs.
Wow.
Yeah, so there's like millions of chicken eggs that you need for that. So, and they have to be all fertilized and have little chicks in them. So it's, it depends. So, but the actual manufacturing is pretty figured out. I think it's not the bottleneck. The bottleneck is quality control, safety testing, and all of that other stuff that every single batch that your manufacturer has to go through. So if you take flu vaccine, for example, as an example of the vaccine that has to be produced every year, so the cycle is pretty much that long. So it's usually 9 to 10 months from the time that we say, okay, this is what we're making, to the time that you and I get the jab.
Right.
That's that long. So, and most of that time is not physically making it. Most of this time is making sure that the process produces what we want, that it's consistent, that it's of high quality, purity, that it's safe and effective, and then actual distribution, shipment, and all of that stuff. So but again, it can be accelerated, of course, but only to a degree. So if, say, tomorrow we know that this particular vaccine is working and approved, it's probably going to be still 3 to 6 months before people will actually start getting it. So it's not going to be instant.
Right.
But I know for a fact that a lot of these manufacturers already stockpiling the vaccines. They don't even know if they would work yet, but they are already stockpiling them. So in case that these trials show efficacy, they already have some doses that they can ship out, which again accelerates it greatly.
Right.
But for that, they have to work. So, for example, if Moderna has a bunch of vaccine already made, I don't know how many millions of doses or hundreds of thousands of doses they're already made and ready to go. So the day they get FDA approval, they can start selling, shipping, and distributing.
Right.
So that's called warp speed, right? Right now, this term about this warp speed vaccine development has never been performed before. Like, I think the fastest vaccine that was ever made, I think, was 4 years.
Right. Wow. And so now we're at.
So from scratch, because influenza vaccine, it changes every year, but it's the same type of vaccine. It's just the one gene or two genes in it are slightly changed, but process, everything is identical. We know what we are making.
Right.
But this is completely new virus, new pathogen, new vaccine. So the fastest it's been done was 4 years. So right now we are not even a year yet in the actual, since we knew what the virus is and what's happening. So if in early 2021 there is a vaccine that, like, unprecedented, is 4 times faster than it's ever been done. So that would be pretty impressive.
Crazy. Okay. And then just to go back, so for, say, the Moderna trial, you were saying, like, so we have social distancing measures or physical distancing and people are wearing masks, but in order for us to actually test if the virus or if the vaccine works, we need people to actually get the virus. So, like, are these trials then superseding government instructions about
No, nobody would ever advise anyone to not follow the protocol. So people are expected to follow all the guidelines. Just like people are expected to follow guidelines right now, but there are still new infections. So nothing is perfect, right?
Right.
So that's why so many people are enrolled in the trial, because presumably those are conscientious people who follow rules. So probably infection rates will be low in that group. And that's why we need so many people to get, I don't know, a couple of hundred of people infected for statistics to work and to figure out whether the vaccine is effective or not. It's unethical to ask someone to get infected and give them placebo, right? So it's not how it works.
Right.
So they're still supposed to mask. They're still supposed to social distance, but they're not obviously isolated. They still live their lives as you and I.
Right. So, I know this is an ethical dilemma, but could you make, like, because we're on our best behavior right now, that will inadvertently slow down the progress of the vaccine? Not compared to normal times, because I know it's already going super fast, but
I don't think so. I think just for sheer numbers, the Atlantic provinces is more of an anomaly right now, and I think there's many factors to why there's such low numbers here. But I'm sure there's a lot of people who are trying their best in Quebec and Ontario and BC, and still a lot of people get infected. And same in US and Europe. So I think it's just, as I said in the beginning, the virus is super contagious, and it doesn't take much to slip and let your guard down and think you're safe and end up not being safe. So it's all the magic of large numbers, right?
Right.
Millions of people, even if 99% of them are perfectly protected, that 1%, the million is 10,000 people. So,
right.